किरण, सॉरी रवि कुमार, नॉट रवि किरण, सॉरी रवि किरण, ठीक है। चलो बच्चा, रवि किरण सिंह सर, आई डिडंट से एनीथिंग, नो प्रॉब्लम बच्चा। It was Ravi Kumar Husmani. Good evening to all of you, or good afternoon to all of you, whatever you want to say, whatever you want to feel like. So guys, as it was announced to your group that this class is for all of you to attend, होला होला। तो आपको करना क्या है, आज की जो क्लास है वो कॉमन है, दैट विल बी लाइक बोर्ड्स प्लस कॉम्पिटिटिव, सो सब मिक्स्ड है, खिचड़ी पढ़ेंगे आज, ठीक है। तो जिनको खिचड़ी पसंद नहीं है, पसंद करना शुरू करो। सो टुडे विल स्टार्ट विद लेंस, ठीक है बच्चा। सो टुडे फॉर सम theoretical part I have actually made I have actually prepared the notes already, just to save some time, ठीक है। तो मैं कुछ क्या कर रहा हूँ कि कुछ नोट्स को पहले ही मैंने सेव करके रखा है। Pritish, was that for competitive class और boards class की बात कर रहे हो Pritish? Which questions you are talking about? Last class का वो हम लोग competitive class में करेंगे बच्चा, boards में हम नहीं करते हैं, ठीक है। Because बहुत सारी चीजें पढ़ाना है हमें। So as you can see, this is the 12th lecture of ray optics, and we are just going to touch this lens. We are just going to start lens, and there's so many other things are also that have to be taught to you. In competitive तो बहुत सारी चीजें पढ़नी है, ठीक है। So थोड़ा सा सब्र करो, मैं करा दूंगा सब कुछ। तो आज बच्चा लोग कुछ शुरू कर दे, because see why am I going for this as a common class, उसका reason है बच्चा, because we have missed 2 classes, right? एक Monday और Tuesday को miss किया, and then 1 class was on 2nd of October, that means yesterday. So if I don't teach you enough in boards classes, I can't be able to like teach you the competitive parts or some extra points so that we can solve some numericals. तो हमें थोड़ा boards में आगे बढ़ना होगा, ठीक है। So that is what, and then we have also missed 1 or 2 classes last week also for boards only. So इसलिए मैंने Saturday को सबके लिए common class रखा, so that कि till Wednesday we'll be covering almost all the aspects of ray optics which is related to refraction. So then next week, Thursday, Friday and Saturday, we can solve some numericals, we can study something extra. And then next week, like next to next week, we can start with optical instruments, and we can finish it off like before 15th of October or 16th of October. So this is my plan, that I want to complete this chapter within 2 weeks, or yeah, within 14 to 15 days. Maximum 12 classes I want to take here, ठीक है। तो 12 क्लास में मैं खत्म करना चाहता हूँ। Otherwise it will be very very lengthy, and it'll become very very monotonous also. And if you see the number of questions that will be asked to you from this topic will be maximum 2 यार, ठीक है। तो 1 या 2 क्वेश्चन पूछा जाएगा, and for that if you have to study like 2 months continuously or 1 month continuously, don't you think that will be थोड़ा सा monotonous? So that is why I'm trying to finish it off in less than 24 classes, ऐसा करके। But normally ये बहुत लंबा चैप्टर है। Anyway, so बच्चा लोग चलो शुरू करते हैं लेंस से। So what is लेंस बच्चा? रिकॉर्डिंग शुरू हो गया बच्चा लोग। So जिसको भी प्रॉब्लम था उस रिकॉर्डिंग से, रिकॉर्डिंग शुरू हो गया, डोंट वरी। So what is lens बच्चा लोग? So lens क्या है? As I have given the definition, so a lens is a piece of transparent material. Lens is a piece of transparent material with 2 refracting surfaces. जहां पे कितने surfaces होंगे? 2. With 2 refracting surfaces such that at least one is curved, and refractive index of its material is different from that of the surrounding. All right, so that kind of transparent material will be called as lens. होना क्या चाहिए? Minimum 2 refracting surface होना चाहिए. So minimum 2 refracting surfaces should be there, and one of them must be curved. If both of them are like plane or parallel, तो क्या हो जाएगा बच्चा? If both of them are not, if both of them are plane or parallel or plane, so what will happen? It will become a glass slab. So magnification नहीं होगा, simply क्या होगा? सिर्फ shift होगा, and there'll be some apparent shift and lateral shift of the rays of light. But lens में क्या करना है? एक surface minimum curved होना चाहिए. If the curved surface of lens is spherical, ठीक है, आपने जो the lens which you're talking about, if the curved surface of that lens is what? Spherical, then the lens is called as spherical lens. ठीक है, then the lens is called as spherical lens. And if thickness is small, then the lens is called as thin. In our syllabus, we need to talk about thin lenses only. हम किसकी बात करेंगे बच्चा लोग? जो हमारा syllabus है उसमें क्या पढ़ना है? Thin lenses. So we'll not be talking about thick lenses, we'll be talking about the thin lenses. Thin lenses का मतलब क्या है? the thickness of that lens must be small. And we'll talk about spherical thin lenses. In our syllabus हम क्या पढ़ते हैं बच्चा लोग? Spherical thin lenses. However, you can be asked some kind of question also, like where one of the surface will be spherical, or कुछ दूसरा फॉर्म भी दिया जा सकता है, but वो हमारे सिलेबस में नहीं है. हमें क्या पढ़ना है? Spherical thin lenses, where the thickness will be very small. यहाँ लिखा है देखो, we have to study about thin lenses. A lens is said to be thin if the gap between the two surfaces is very small. So there are two types of lenses. You must have studied this already. एक होता है convex lens and the other one is concave lens. So there are few varieties of convex lens also. If you are going to get a lens like this, okay, these are the two refracting surfaces, and both of these surfaces are what? Spherical. So this is what? A spherical convex lens. But when you are going to see a lens like this, we call this as biconvex lens. ठीक है, इसको हम क्या बोलेंगे? Biconvex lens. If the R1 and R2, radius of curvature of this refracting surface, radius of curvature of this refracting surface, if both of them are same, then we can call that as equiconvex lens. So क्या बोलेंगे बच्चा लोग? Equiconvex lens. If one of the refracting surface is plane and the other one is spherical, like this, this is called as plano-convex lens. So क्या बोलेंगे बच्चा लोग? Plano-convex lens. Then fourth one, if you are going to have a if you are going to have pair of refracting surfaces like this, one of them is like this one, like concave towards this, another one is what? Concave towards this. This is called as concavo-convex lens or concave convex lens. This is called as. So these are the four types of lenses that we need to think, or we have to see in our questions. All right. In concave lens, similarly, if you're going to see this kind of arrangement, okay, then we can call this as biconcave lens. If radius of curvature of both the refracting surfaces will be same, we can call equiconcave lens. If one of them is concave, the other one is, let's say, plane, so we can call plano-concave lens. And if it looks like this, एक concave हो गया और इधर से convex आ गया, so we can call this as convexo-concave lens. Okay, so these are you can say the conventions that we follow to explain these types of lenses. If you have been asked, draw a convexo-concave lens, तो कैसे draw करोगे? So like this. This will be what? A convexo-concave lens. ये हो गया types of lenses. Now, when we talk about refraction through lens, we should also talk about ray tracing. Ray tracing means how you are going to draw the ray diagram. Ray diagram means the incident ray and the refracted ray. So there are three rules that we have to follow for ray tracing. So rules of ray tracing में तीन हमने add किया है. So these three rules have to be followed. These three principles have to be followed for ray tracing. And I'm expecting all of you must know this because you have already studied these things in standard 10th. But I'm just going one by one, just for the sake of revision. देखो बच्चा, तो one is the ray parallel to the principal axis, which after refraction passes through focal point F1. तो पहला ray है, one मतलब पहला ray. One is the ray parallel to principal axis. That means if incident ray is parallel to principal axis, after refraction it will pass through F2. What is F2 बच्चा? बोलो बच्चा, what is F2? F2 क्या है? What is F2 here? We have studied this last class. It is secondary focal length. Sorry, secondary focus. Capital F लिखा मतलब focus. Focus point की बात की, ठीक है? So the ray parallel to principal axis after refraction passes through focal point F2. ठीक है? चलिए. Second part बताइए चलो. Second point क्या है बच्चा? So second ray is the ray that passes through the first focal point. ठीक है? Second क्या है बच्चा लोग? Second ray is the ray that passes through first focal point F1 of the lens. After refraction, it travels parallel to the principal axis. That means if incident ray is passing through the primary focus, if incident ray is passing through the primary focus, the refracted ray will be what? Parallel to the principal axis. This is the second rule or the second ray we are talking about. If you want to draw one more ray, so the third ray, तीसरा ray की बात करें, the third ray usually called chief ray. इसको क्या बोलते हैं बच्चा लोग? Chief ray. ठीक है? Called chief ray goes through the optical center of the lens, emerges without deviation. So the third ray will be what? Will just, if the ray which is passing through, if there is a ray which passes through the optical center of the lens, then it will go undeviated. I think last class few of you have asked me, sir, how is this possible? Like how does no deviation occur? तो इसका बहुत ही आसान सा सिंपल सा रीजन है बच्चा लोग. इफ यू आर हैविंग अ लेंस लाइक दिस, ठीक है, एंड इफ एक्चुअली ऐसा होता है कि द अमाउंट ऑफ डेविएशन, amount of bending that occurred at the first refraction like this, the same amount of deviation or the refraction will occur at the second interface in opposite direction. So you can also assume that these two rays, if you draw these two rays, let me draw it. देखो बच्चा, if you draw lens like this, ठीक है, and if you consider a ray of light passing through, this is the optical center. This is the optical center. So what happens actually? The amount of deviation or देखो क्या होता है, यहां से ऐसे आता है, and then it will actually come like this, which seems parallel to these lines, like this incident ray and emergence ray. They'll be what? Parallel to each other. But when the thickness of the lens is very, very small, when the thickness of the lens is very, very small, the parallel lines will be very, very close to each other like this. एकदम बिल्कुल चिपक चिपक के रहता है. एक मिनट रुक जाओ, बनाने दो. हाँ, so these parallel lines will be very, very near to each other. ऐसा कुछ, ठीक है. So if I consider this as the incident ray, if I'm actually drawing this here and if I'm drawing this here, so what will happen? Incident ray and emergent ray, both of them will be parallel. अगर ऐसा parallel होता, but if this lens is very, very thin, so what will happen? This distance between them will be very, very small. You know what is the difference? What is the distance of lateral shift, right? We have derived this lateral shift formula. क्या मिला था? D divided by something, right? D into sine of I minus R divided by sine R. Sorry, cos R. If that D is very, very small, this shift will be very, very छोटा. In slab, consider, याद करो, slab में पढ़ा है ना हमने. So at the pole, you can consider a single छोटा सा slab. At the pole, you can consider a छोटा सा slab, because at the pole, if you consider a very, very small slab, very, very thin छोटा सा element, you can consider this is what, these two are what, parallel surfaces. You can consider this as a slab. So incident ray is coming here and then coming out of this from this side. So what will happen? The incident ray and the emergent ray will be parallel, but the distance between them will be very, very small. So this definition or this rule, the third rule, which says the third ray goes through optical center of the lens, emerges without deviation, is valid only for बच्चा, किसकी बात कर रहे हैं? सब सारा का सारा valid only for thin lens. If lens will be thick, if the distance between refracting surfaces will be bada, will be considerable, you cannot say that they'll go undeviated. However, deviation will be zero, but they will not pass through the same line. They'll not be following the same line. Agar incident ray is like this, emergent ray might be like this or might be like this. They'll be offset. They'll be parallel to each other. But guys, yes, deviation will be there. No, in this one, deviation will be zero because parallel में deviation क्या है? Zero है ना? Parallel में deviation क्या है? Zero. But there'll be distance, there'll be some shift that will occur with the emergent and incident ray. All right, guys. So you can assume this or you can explain this by considering the part of the lens. Okay? Yeah, lateral shift. The part of the lens at the optical center will act as a glass slab, having thickness very, very small. So the lateral shift will be very, very small. So I can say that the incident ray and emergent ray will be parallel, but lateral shift is so small that can be neglected, and hence we say that incident ray and emergent ray will be what? Will pass through the lens passing through optical center without any deviation, without any change in path. तो बीच का जो पोर्शन होता है ना, मैं खा जाते हैं उसको, यहाँ जो डेविएशन खा जाते हैं, सीधा बोलते हैं ये साथ में पास करेगा. All right, guys. So this is what the third point means. All right. Now let us come to original business, जो हमारे एग्जामिनेशन के लिए जरूरी है. And what is that? चलो, lens maker formula. ठीक है? You can be asked directly this derivation, that derive or obtain an expression for lens maker formula. Derive an expression for lens maker formula. ठीक है? So in NCERT book and all, they have given proper derivation also, but I consider this derivation as थोड़ा सा ज़्यादा simpler है. ठीक है. As long as you explain everything clearly, what is mu2, what is mu1, what is v1, what is v and all, you will get the exactly same marks as you will get if you follow the NCERT derivation. बिल्कुल same है, but they have just taken some different conventions, like they'll consider mu2 as n2, mu1 as n1. ठीक है, थोड़ा complicate हो गया है. So what does this lens maker formula suggest बच्चों? This will give you relation between focal length and radius of curvature. ठीक है, और radii of curvature. तो देखिए क्या किया हमने, to get this relation, to get this formula, we are considering a thin lens. Having refractive index mu2. And the surrounding medium is having refractive index mu1. But both the sides of lens should be having the same refractive index. ऐसा नहीं होना चाहिए. This will have some refractive index mu1. This will have refractive index mu3. Then this derivation will be wrong. Condition क्या बच्चा? Both the sides of the lens must have the same refractive index. All right, guys. Then only this formula will be applicable. So what we are considering? We are considering refractive index of the lens is mu2 and refractive index of the surrounding is mu1. Surrounding means both right, left, or wherever it is. So refractive index of the medium outside the lens is mu1. बहुत बढ़िया. Now let us try to get a relation. Try to use refraction formula for refraction through first surface. If I use refraction formula for first surface, we know the formula as mu2 divided by v minus mu1 divided by u is equal to mu2 minus mu1 divided by radius of curvature r, right? Chaliye. If I talk about this, let us consider the image distance for first refractive surface is v1. So I'll write mu2 by v1 minus mu1 by u. What is u? Object distance. Mu1 by u, object distance, will be equal to mu2 minus mu1 divided by r. Okay? I'm just using the refraction formula. I'm not putting the values and all. I'm just using the refraction formula that we have obtained. Okay, चलो चलिए, ये हमारा first surface के लिए refraction formula हुआ. अच्छा, if I ask you to use refraction formula for second surface, tell me guys, what will be the object for second surface? Tell me what will act as an object for second surface. Will this point O act as an object for second surface or something else? Come on guys, tell me the answer. Will point O act as an object for second surface? Guys, tell me the answer. No. This object O, this point O is an object for first surface. And the image for O will act as an object for second surface. All right. So the image of first surface will act as an object for second surface. That is why at the place of U, we have put V1 here. At the place of U, we have put the value V1 here. And the sign conventions, you have to put the sign conventions here. That is true. Okay? But if you put the value of V1, then you have to put the sign convention. Otherwise, kya hai, chalo? So the image for first surface will act as an object for second surface. So instead of putting the value U, so at the place of U, you have to put the value of V1. So what is the image distance for second surface? So I have considered that as V, because that will be the final image. Image of second surface will be the final image. So I have considered that as V. So when I talk about refraction through this surface, this is the medium in which incident rays like propagating. This is the medium in which refracted rays is propagating. So I have to write mu for the refracted ray. That means यहाँ क्या लिख देंगे mu1. ये बाहर का है, याद करो. We were having something like this. This was mu1. This was mu2. What was mu1? The refractive index of medium in which incident is traveling. What is mu2? Refractive index of the medium in which refracted ray is traveling. So when we talk about refraction through second surface, what is the refractive index of the medium where incident ray is traveling? Where incident ray is traveling in glass, in this lens. So which value we should consider? mu2. तो ये हो गया क्या? Object का, incident ray का. So that is why I have written in at the place of u. So and what about the refracted ray? mu1. So I'll write mu1 by v minus mu2 by v1 will be equal to. Here what should I write? mu1 minus mu2 by r2. mu1 minus mu2 by r2. So these two, यहाँ पे एक r1 हो जाएगा बच्चा लोग. This will be what? r1. So these two equations that will get if I use refraction formula at these two refracting surfaces. Guys, click yes if you have understood these two relations. But chalo, click yes if you have understood these two relations. We have already studied refraction formula last class, ठीक है, वो डेरिवेशन में हमने किया है. So we are just following that refraction formula here, ठीक है, उसी का हम लोग सिर्फ यहाँ यूज कर रहे हैं. Once we'll get these two equations, can I say mu2 by v1, mu2 by v1? Both the equations contain mu2 by v1, but in one equation there is a positive sign with it, other equation there is a negative sign with it. And we are not interested in the value of v1. We are interested in the relation between v, u, f, and so on. Okay? So what will I try to do? I will try to eliminate this v value. क्या करेंगे बच्चों लोग? I will try to eliminate this v1 यहाँ से. Okay? So just add these two equations. क्या करेंगे बच्चा? So add these two equations. If I add these two equations, can I say they'll get cancelled? So I'm going to get mu1 by v. देखो यहाँ पे mu1 by v minus mu1 by u. Sorry यहाँ correct. mu1 by v minus mu1 by u will be equal to, if you add these two, तो यहाँ पे देखो एक minus sign है ना. Here we are having a negative sign. So what will I write? I will take negative sign from here and say I'll take mu2 minus mu1 as common. So mu2 minus 1 u into 1 by r1. इधर minus sign है तो minus 1 by r. So this can be written as, actually this has been written like this, minus mu2 minus mu1 divided by r2. And then it has been added. So if you add it, you're going to get this equation. If I bring mu1 on the right hand side, I will get 1 by v minus 1 by u is equal to mu2 by mu1 minus mu1 by mu1 is 1, so minus 1. ठीक है? Into 1 by r1 minus 1 by r2. अथर्व रुक रहे, नहीं तो मैं बता रहा हूँ जोर से डांटूंगा. ठीक है, अभी रुक. मैंने पढ़ाया क्या? पूरा कंप्लीट किया क्या? अदरवाइज मैं सीधा ब्लॉक कर दूंगा तुझे. एक ही मैसेज को 10 बार लिखने से मैं उसको ज्यादा वैल्यू नहीं दूंगा. ठीक है, सिर्फ डांटूंगा. चलो तो I got this 1 by v minus 1 by u is equal to mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. ये पार्ट मिल गया. Now I got relation between 1 by v, 1 by u and this part. Alright बच्चा, अभी देखो, if I put the value of u as infinity, if I put the value of u as infinity, tell me what should be the value of v बच्चा लोग? If I put the value of u as infinity, tell me what will the value of v? So v will be what? F, the focal length. Correct है? So क्या करेंगे? तो 1 by f, देखो यहाँ वैल्यू पुट करो, तो 1 by f minus 1 by infinity, this will become 0, will be equal to mu2 minus mu1, sorry, mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. So this equation I'm going to get. If I use u is equal to infinity and v is equal to f here, I will get a relation between f and r, focal length and radii of curvature. So this equation is nothing but lens maker formula. ये equation क्या है बच्चा लोग? This equation is nothing but lens maker formula. All right, guys. So this equation is called as lens maker formula. So from this part, I know that right hand side mu2 minus mu1 into mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2 is equal to 1 by f. So if I put the value of this part here, I will get 1 by v minus 1 by u is equal to 1 by f. So this equation is called as lens formula. इसको क्या बोलते हैं बच्चा? Directly क्या बोल देते हैं इसको? Lens formula. But however, if you write this also, दोनों का कहानी same ही है. If you know the value of f already, you'll use this equation to get the image and object distance. If you don't know the value of f, you just know the media, you know the properties of the media, and if you know the radii of curvature, then you have to find the value of f. तो उसके लिए हम ये इस value का use करेंगे, इस equation का use करेंगे. So this relation, this formula is called as lens maker formula, and this equation is called as lens formula that you might have studied in standard 10th. Yes, Rahul, it can be asked. Guys, click yes if you have understood this derivation. Guys, click yes if you have understood this derivation. Clear है सबको? चलिए अब आगे बात करते हैं मित्रों. So next is what? Limitation of lens maker formula. What are the limitations of lens maker formula? So there are two limitations that you have to remember. कभी कभी 2 नंबर में पूछ देता है. Yes, Ravi Kiran, here R1 is equal to R2. If I say so, बच्चा, if I say R1 is equal to R2, then if I say R1 is equal to R2, then otherwise they might have different radii of curvature. These two surfaces might have different radii of curvature. तो चीज आपको ध्यान देना होगा, हमेशा assume मत कर लेना same. They can be biconvex lens also. Don't assume equiconvex lens every time. Okay. Let us study the limitations of the lens maker formula. ठीक है, तो हम पढ़ेंगे lens maker formula का limitations. So there are two limitations of lens maker formula. Guys, please remember these limitations. They can be asked to you in 2-mark question in your board examination. तो क्या क्या limitation बचा? तो first one is what? Lens should be thin. Lens should be thin so that the separation between the two refracting surface should be small. तो जो लेंस हम लोग यूज कर रहे हैं, दैट लेंस हैज टू बी थिन, वो बिल्कुल पतला होना चाहिए. अच्छा, सेकंड लिमिटेशन क्या है? सो द मीडियम ऑन द आइदर साइड ऑफ द लेंस शुड बी सेम. The medium on the either side or either side of the lens must be same. If any of the limitation is violated, then we have to use the refraction at the curved surfaces formula for both the surfaces. If any one of them is what violated, what do you have to do? You have to use these two formulas separately. You cannot use these two use this formula at the end. तुम्हें refraction at first surface individually calculate करना होगा. You have to analyze refraction at second surface individually. If any of the condition has been violated, you have to analyze that particular condition by considering refraction at each of the surfaces separately. Okay, you won't be able to use this formula. All right, guys. So these are the two limitations that you have to consider. Guys, is background noise is too much? Is it disturbing you all? थोड़ा थोड़ा अभी भी हो रहा है क्या? चलो, let us see if it continues. I'll do something about it. Don't worry. चलिए, so these are the two limitations. Now let us talk about some numericals. Come on, guys. Now give me the answer for this question. No, प्रणव, रोड वर्क नहीं हो रहा है, वो घर में काम लगा हुआ है, तो पता नहीं ऊपर. अरे यार, क्या तोड़ रहे हैं लोग, घर ही तोड़ देंगे पूरा. एक मिनट रुक जाओ, मैं कुछ तो करता हूँ जुगाड़. ठीक है गाइस, प्लीज सॉल्व दिस क्वेश्चन. I'll do something. डोंट वरी गाइस, इट विल बी सॉर्टेड. ठीक है, वो बंद कर देगा अभी काम. चलो बच्चों, जल्दी से आंसर करो इसका. डबल कॉन्वेक्स लेंसेज आर टू बी मैन्युफैक्चर्ड फ्रॉम अ ग्लास ऑफ रिफ्रैक्टिव इंडेक्स 1.55 with both faces of same radius of curvature. So R1 is equal to R2 given to you. What is the radius of curvature required if the focal length is to be 20 centimeter? If the focal length is to be 20 centimeter, what should be the radius of curvature required for the lens? So I've got two answers, one from Advait, other one from Tanya, third answer is from Janvi, and all of them have given the answer as 22 centimeter. Aditi DS 22, Pooja Munyal 22 centimeter, Vijeta 22. So everyone is saying 22. Now I can't read all of your names. Samriddhi, Saksha, okay, ठीक है. Sakshi, Pranav. So everyone is saying 22. Let us figure out, bachalo. Let us see whether they are saying correct or not. Double convex lens है, ठीक है. Lens use किया. R to be manufactured from a glass of refractive index 1.55. So mu2 is given to us as 1.55. ठीक है. mu2 is given to us as 1.55. What is the value of, yeah, So focal length is given to us as क्या बच्चा लोग 20 centimeter. Let us use the formula. What is the formula for focal length? How can we find the focal length बच्चा लोग? तो 1 by f is equal to mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. All right guys, let us put the values. ठीक है बच्चों, तो convex lens में focal length क्या मिलता है मुझे? Positive. Which focal length we talk about here? चलो tell me. We have studied two types of focal length, right? Two focal lengths. Which focal length we need to consider here? Primary or secondary? Come on guys, tell me. Primary or secondary? फंस जाएगा बच्चा, कल ही बात हुई है, लास्ट क्लास में ही पढ़े थे हम लोगों ने. We talk about primary focal length, primary principal focal length और secondary principal focal length. We always talk about secondary. ठीक है, उस चीज का ध्यान देना बिल्कुल. That is why ना देखो, parallel rays of light comes meet at focal length, focus. So this is f2, right? Image distance, ठीक है, for object at infinity is secondary focal length. So this is secondary focus. And for a convex lens, where the secondary focus lies, bacha, so along the direction of incident ray. So that is why for when you say the focus or the secondary focus for a convex lens will be positive, इसका meaning क्या है? इसका meaning we are talking about this f2. So when we say focal length, actually we are talking about f2. तो ये f2 का वैल्यू क्या मिलेगा? Positive for convex lens. So it will be positive for convex lens. You have to draw the diagram, you'll get it clear. ठीक है, चलिए. Now let us put the values बच्चा लोग. तो 1 by 20 is equal to mu2 is what? 1.55 divided by what is mu1? It has been kept in air. So 1 minus 1 into 1 by r1. We don't know what is the value of r. Guys, tell me what will be the value of r1, whether we have to consider r1 as positive or negative, because this is the first refractive surface. So radius of curvature for first refractive surface. So the center for this will be what? Towards right, somewhere here. So distance will be measured from pole, so it will be what? Positive. So r1 will be positive. Let us consider that value is r, so plus r minus. What about r2 बच्चा लोग? So this is the second refractive surface. This is the second refractive surface. And the center for this will be somewhere here. And distance of center of curvature from pole will be measured towards left. So negative. Okay? So guys, if you don't use this convention, you will get 0 minus 0. Sorry, 1 by r minus 1 by r will be 0. Then you'll give some बहुत गंदा सा answer. That is why you have to use the convention here. So now what will be the answer? So 1 by 20 is equal to 0.55 into 2 divided by r. इसको solve करेंगे बच्चा लोग क्या मिलेगा? r will be equal to 1.1 divided by 20. तो मैं क्या करता हूँ? 5 से multiply किया, 5 से multiply किया. Guys, did you get the same answer? मेरा कुछ अलग आ रहा है, आपका कुछ अलग कैसे आया? Did I commit any mistake बच्चा लोग? Guys, did I commit any mistake? Why am I getting something else? Tanya, what did I, like, where did I commit mistake? All right, it should be into 20, correct. It should be into 20, my bad. So it should be into 20. हाँ, सुबह अभी पहले ही क्वेश्चन है, भांग का असर हो गया. तो what is the answer here? 22 centimeter. 1.1 into, yeah, correct. It should be multiplied because it is in denominator here, right? So इधर लिया मैंने. So 22 centimeter is the correct answer. So r is what? 22 centimeter. Radius of curvature required for this lens will be 22 centimeter. This is the answer. So each one of you have given the correct answer. Well done, guys. Keep it up. Now, guys, give me the answer for this question. Let us see how many of you can answer this. A beam of light, Suryamukhi effect, because अभी तक रात नहीं हुआ. क्या रे प्रणव, हर बात पे जोक मारना जरूरी होता है क्या? 9.8 आंसर करो. This is an exercise from NCERT. 8th question from NCERT. मजा आता है, बहुत बढ़िया है. चलो चलो जल्दी आंसर करो. A beam of light converges at a point P. Now a lens is placed in the path of the convergent beam 12 centimeter from P. At what point does the beam converge if the lens is? Option A, convex lens of focal length 20 centimeter. Option B, a concave lens of focal length 16 centimeter. Come on guys, solve it. There are 2 questions you have to answer. Pranav, ऐसा नहीं होता है. I'll never do that. If you are saying something in the class, I'll take your name. If you think that is correct to say in the class, why do you care about whether I'm taking your name or not? If it is being recorded, it's good, na? You're being famous. Like guys from Bangalore, guys from Belgaum, Tornagalo, Mumbai, Maharashtra, Kerala, सब जगह के लोग तुम्हें जान रहे हैं. And if one or two from one or two students from other parts of the country are also looking at or watching the videos, they'll also get to know there is a Pranav. If you want me to take your full name, I can take that also. Pranav Sivakumar P. So no issues. Chalo, jaldi answer karo. So Pratish is saying first one is 30 centimeter. Anya is saying first one is 7.5 centimeter. Guys, convention ka yaad rakhna. Don't commit mistake while taking the sign. Pooja Monyal is also saying 7.5 centimeter for first one. How is that related to this class, bacha? Okay, Pratish, no issues. Check kar lo ek baar. Rahul is also saying 7.5. Prajwal 7.5. Samriddhi 7.5. Mohit 7.5. Okay, so everyone is saying 7.5 for the first one. Sapne dekhte raho, Pranav. You will be positive. Very good, Prajwal. Very good. Keep it up. Bahut badhiya. So Samriddhi has given an answer for second one also. Second one is 48 centimeter according to Samriddhi. Vijeta is also saying 48 meter for second one. Aditi DS first 7.5, second 48. Okay, बहुत बढ़िया बच्चा लोग. चलिए solve करते हैं. So a beam of light converges at a point P. ठीक है, तो a beam of. अच्छा guys, what is beam of light? I didn't give you definition for those. बहुत टाइम लगता है वो सारी चीजें बताने में. Tell me guys, what is beam of light? What is the meaning of beam of light? See guys, if you refer any book ना, तो book में बहुत सारे definitions मिलेंगे. Ray of light का, beam of light का, या collection of light rays. That's it. A beam का मतलब क्या है? पूरा rays का बहुत सारा collection, bundle of rays. Yeah, correct. So that is called as beam of light. Okay? चेतना, ओ तेरे auto correct ने rays को rats कर दिया. चलिए, so there is a beam of light which is what? Converging at a point P. So these are the two rays I'm considering. They are converging at point P. बीच में क्या किया गया बच्चा? बीच में एक रखा गया पहली बार में convex lens. A convex lens has been kept in between the path. So question is, find out or at what point does the beam converges if or does the beam converge if the lens is a convex lens. ठीक है, तो ये part. Let me delete this part because ये तो ऐसा होगा नहीं. If this is the principal axis. तो देखो बच्चा, निकालते हैं कि कौन से पॉइंट पे ये मीट करेगा. तो कैन आई से गाइज, फॉर दिस पर्टिकुलर कंडीशन, for this condition, I would say if we extend these points by dotted line, can I say they are going to meet at this point? This is the point P. And these two lines are what? Incident rays. So for this optical device, for this lens, which is the object, I will say this point P is the object. So can I say P will act as an object? P will act as an object. What is the distance of this point P from the object? So it is given to us, that is 12 centimeter. So what will be the value of U here? It will be positive 12 centimeter. Virtual object, U will be positive. Real object, U will be negative. Okay, not U. U means the value of small u, the letter U. Okay, so U will be positive and that will be 12 centimeter. We need to find what will be the image length, because focal length is given to us 20 centimeter. Since convex S, so plus F. So I'll use 1 by V minus 1 by U is equal to 1 by F formula. I'll get the value of 1 by V as 1 by F plus 1 by U. Put the value 1 by 20 plus 1 by 12. What will be the LCM बच्चा? तो LCM will be 60. ठीक है? LCM will be 60. हाँ, तुमने वही गलती किया प्रतीश, इसलिए गलत हुआ. It will be sorry, it will be 3. It will be 5. Correct है guys? So what will be the value of V now? So V will be equal to 60 by 8. So 15 by 2. That means 7.5 centimeter. We got V as positive 7.5 centimeter. That means it will be converged to the left of P, because the distance of this point P from this lens is 12 centimeter. 7.5 means less than 12 centimeter. So where these rays will converge, तो ये कुछ इधर ऐसे बीच में converge कर जाएगा. So I can say this distance would be 7.5. And this will be P dash. All right, guys. Guys, click yes if you have understood this. I know most of you have given the correct answer, but still very few of you have given the answer if I compare the total population. ठीक है? बहुत कम लोगों ने, जिन लोगों ने आंसर किया, almost every one of you have given the correct answer. Very good, guys. Ravi Kiran, याद करो. What is an object? Ravi Kiran is asking, sir, how can we consider P as the object? So Ravi Kiran, I think you are missing out a very important point, a very important definition for an object. Who do you consider as an object? First revise that, you'll get the answer. Okay? चलिए, second case की बात करते हैं चलो. In second case, what will happen? U will be positive 12 only, no problem. So B. What will be the value of F बच्चा लोग? F here will be what? Negative, because we are talking about concave lens. In concave lens, focal length will be negative, and the focal length is given to us as 16, minus 16 centimeter. So now use the formula. So 1 by V will be equal to 1 by F plus 1 by U. So 1 by minus 16 plus 1 by 12. LCM will be 48. So I'll get minus 3 plus 4. Answer will be 1 by 48. So V value is nothing but plus 48 centimeter. So what is the meaning of plus 48? तो पहले हम बना लेता हूँ concave lens, ठीक है? Guys, I'm drawing lenses which doesn't look thin. इसका ये मतलब नहीं है कि I'm taking thick lenses. I'm drawing them so that it will make some sense. So let's say they are going to meet at this point. If you converge them, if you allow them to meet, they'll meet, let's say, at this point. This is point P. But after refraction, what will happen, बच्चा लोग? It will actually diverge. क्या होगा? ये इधर से diverge कर जाएगा. It will meet at some point like this. कहीं तो इधर ऐसा meet करेगा. So this distance can be considered as 48 centimeters. This will be E dash. All right, guys. So this will be the diagram for second case. So guys, tell me which one of them will converge more. Which one of them will have more converging capability? कौन सा converging capability? Concave lens or convex lens? As you can see, if two converging rays of light or converging beam of light is coming, if converging beam of light is traveling, and if on the way, if a concave lens have been put, what happens? The converging point actually moves away. That means this lens will act as a diverging lens. इसको क्या बोलेंगे बच्चे? Diverging lens. This actually diverges the lens. Sorry, this diverges the ray of light. What about convex lens? It actually converges the rays of light further. So these were the two converging rays. And when we put a lens in between the path, what happens? It again converges. That is why we call a convex lens as a converging lens also. We call a concave lens as a diverging lens also. But this is not true for all the conditions. Guys, can you tell me a condition where A concave lens can be used as a converging lens. बोलो बच्चा. Guys, can you give me a condition? Virtual object question. ला. देखो बताता हूँ बच्चा, ध्यान से देखो. देखो, consider this is a lens, all right? Let me draw one more lens. Consider this is mu2, this is mu2, all right? This is mu1, this is mu1, this is mu1, this is mu1. If mu2 is greater than mu1, if mu2 is greater than mu1, you can consider this is what? A converging lens, no problem. But at the same time, if the relation between mu2 and mu1 is reverse, that means the refractive index of the lens is less than the refractive index of the medium. Consider in water, आपके पास एक water ऐसा है, ठीक है? इसके बीच में आपके पास एक ऐसा एयर बबल आपने ऐसा क्रिएट कर दिया. आपने कुछ ऐसा बबल क्रिएट किया यहाँ पे, ठीक है? या फिर वैक्यूम क्रिएट कर दिया यहाँ पे ऐसे. So what will happen बच्चा लोग? यहाँ पे एयर हो गया, यहाँ पे वाटर हो गया. So in this case, what will happen? This will act as a diverging lens. अच्छा, how can we say that this will act as a diverging lens? So I am giving you an assignment. अगर competitive होता तो बताता. I am giving you this you as an assignment. Try to verify this, that in this case it will act as a converging lens. In this condition it will act as a diverging lens. कैसे verify करोगे? By drawing the ray diagrams. तो आप ray diagram बना के देख लो. This is what? Denser. This is having higher value. This is having lower value. So how the ray of light will move away from the normal or towards the normal? ये सारी चीजें आप कर लोगे, समझ में आ जाएगा. So if you draw the ray diagrams, you'll get to know how this will act as a diverging lens, how this will act as a converging lens. Similarly, if you have a concave lens, ठीक है? If you have a concave lens, imagine if you have a concave lens like this. The same concave lens can also act as a converging lens if the refractive index inside the lens, or if the refractive index of the lens is what? Less than the refractive index of the medium. ठीक है? If this is mu2, this is mu1, this is mu1. So in this case, if mu2 is greater than mu1, what will happen? This will act as a diverging lens. If again this is mu2, this is mu1, and this is mu1, if the condition is given to you as if mu2 is less than mu1, then this will act as a converging lens. So never ever try to remember a concave lens as a diverging lens and a convex lens as a converging lens. If you have remembered this till 10th, chalega. But in PU2, you are actually advised not to remember a converging lens as a convex lens and a diverging lens as a concave lens. Because there have been, as I can remember, 2 to 3 instances where questions have been asked like this only. Okay? A lens acting as a converging lens. उसके बाद relation between mu1 mu2 has been given everything. और वहां पे चीजें फिर खराब होती है. ठीक है? So never ever try to remember like this. Concave मतलब diverging, convex मतलब converging. Not like that. हमेशा it depends on the refractive index of the medium and refractive index of the surrounding. प्रतीश कुछ नहीं होगा, दोनों तरफ सेम होगा. आप करके तो देखो ना, समझ में आएगा आपको. Just try to draw the ray diagram, you'll get to know. ठीक है? If you have in competitive class, I would have explained it to you properly. But अभी मैं थोड़ा आगे कुछ और बताना चाहता हूँ. Competitive class में करा दूंगा, no problem. डरो मत. चलो बच्चा. There is one more equation that is very very famous in ray optics, that is Newton's lens equation. You will say sir फिर से न्यूटन आ गया. तो उंगलीमाल डाकू is back. ठीक है? तो Newton has come in ray optics also. देखो कितना चालाक था वो, बहुत ही मतलब कहता हूँ ना, बहुत चालाक होते हैं ये साइंटिस्ट लोग, रिसर्चर्स लोग. So what has he done actually? इसने क्या किया कि सिर्फ ऑब्जेक्ट डिस्टेंस व्हाट वी हैव कंसीडर्ड फ्रॉम ऑब्जेक्ट एंड द डिस्टेंसेस व्हाट वी हैव इमेजिन्ड और व्हाट वी हैव कंसीडर्ड फ्रॉम द पोल, न्यूटन हैज कंसीडर्ड द ऑब्जेक्ट फ्रॉम द फोकस, सॉरी द डिस्टेंसेस फ्रॉम फोकस। उसके बाद इक्वेशन बताया और उस इक्वेशन को क्या बोल दिया गया, लेंस, सॉरी न्यूटन्स लेंस इक्वेशन। So in this Newton's lens equation, we'll talk about the relation between object distance, image distance from the focus. We'll talk about relation between object distance and image distance from focus. This is what we are going to study. ठीक है, देखो तो we have drawn, consider there is an object like this. ये एक upright ऐसा object हमने assume किया. So we have drawn two rays of light. One which is parallel to the principal axis. After refraction, it will pass through the focus. Second ray is what? Passing through primary focus. After refraction, it will become parallel to principal axis. So this is the point at which the image of this upright object will form. So this is the object, this is the image. ठीक है बच्चा? तो ये क्या है बच्चा लोग? Let me write it. This is the object and this is the image. Real and inverted image has been formed. Now we are going to take care of the geometry. अभी देखो बच्चा, if I ask you to get me relation between this distance and this distance, if you talk about these two triangles, देखो बच्चा कभी कभी पूछ देता साक्षी, it's not for your boards but sometimes you can be asked this question, what is Newton's equation? इसका derivation आपको नहीं करना है, they'll ask you simply what is Newton's lens equation. एक मार्क में पूछ देगा, तो for that I'm teaching you here. However, it is not there in NCERT, but in your I think question bank you'll find this question, what is Newton's lens equation? So for that I'm teaching you here. Okay guys, so if I ask you to get me if I consider this angle as theta, this angle as theta, because if this is theta, vertically opposite angle, so this will also be theta. Tell me guys, what is tan theta here then? Can I say tan theta will be this length divided by this length? ठीक है, so I'll say this length is nothing but h1. So h1 divided by this distance is what? Considered x1. So I'll say h1 divided by x1 will be equal to h2 divided by f1. In this triangle, perpendicular by base or opposite side divided by adjacent side. So I'll write h1 divided by x1 will be equal to h2 divided by f1. First equation. Now if I consider this angle as beta, this angle will also be beta. So if I again use tan beta here, I'll say both of them will be same. Tan beta here will tell us, because ये length कितना है बच्चा? h2. h2 is the size of image, the height of image. So from these two triangles, I will say h2 divided by x2 will be equal to h1 divided by f2. So h1 by f2 is equal to h2 by x2. ये पार्ट हमारा मिल गया दूसरा इक्वेशन से. All right guys, did you get this point? If you write these two, now if I ask you to get relation between x1, x2 and f2, tell me guys, how will you get that? Tell me what will be the relation between x1, x2 and f1, f2. Tell me what will be the relation you will be getting. If I ask you to divide equation 1 by equation 2, if this is equation 1, this is equation 2. If I ask you to divide equation 1 by equation 2, can I say I'll get 1 by x1 into 1 by f2? ठीक है, तो f2 will go upstairs, ऊपर चला जाएगा, will be equal to 1 by f1 ऊपर चला जाएगा x2 divided by 1 by x2. So x2 will be upstairs. So what will be the final relation that we are going to get? x1 x2 is equal to, कुछ गलत किया क्या बच्चा हम लोग? Yeah, I think I have committed one mistake here. It will be f1. It will be f1. So x1 x2 will be equal to f1 into f2. So this is Newton's lens equation. So this is the contribution of Newton in ray optics. Guys, click yes if you have understood this Newton's lens equation. Guys, tell me when this f1 will be equal to f2. Can you give me the answer? Guys, tell me, when do you get f1, this length is equal to this length? When will you get f1 will be equal to f2? Tell me, guys. Chetan, wait करो ना, बताता हूँ. When will you get f1 will be equal to f2? तो देखो बताता हूँ क्या. If both these sides lengths have same medium, then f1 will be equal to f2. ठीक है. तो जब दोनों तरफ, if this is also one medium, if this is let's say mu1, if this is also mu2, then the focal length, primary focal length and secondary focal length, both of them will be same. Distance क्या होगा? Same होगा. Or that is why when we consider a lens here and air, lens here or some other medium, same, then we always consider this length and this length as same. ठीक है. तो ये part हम please हमेशा याद रखना. So in that case, Newton's lens law, lens equation will tell us x1, x2 will be equal to f square. All right. Acha. Someone has asked, sir, what is the use of this equation? Use देखो क्या है. Guys, if distances have been given to you from the lens, if this distances have been given to you from the lens, then it's always like advisable to use lens formula, to use a lens formula to get the analysis, to get the distances. But if the distances have been given to you from the focal length, what is x1 बच्चा? यहाँ देखो, what is x1? So x1 is the distance of object, distance of object from focus. ठीक है? From focus. What is x2 बच्चा लोग? It is nothing but distance of image from focus. Clear है guys? Guys, did you understand this? So ये हुआ हमारा Newton's lens equation. Now Tanya has a question. Sir, even for this thin lens is used. Guys, you tell me, do we need to use thin lens for this derivation? Is it mandatory here? Guys, tell me, is it mandatory? Is it like, what is this? Siri, go away. Siri क्यों चल जाता है यार? Tell me guys, whether we need a thin lens to derive this equation? क्या जरूरत है बच्चा लोग? जल्दी से बताओ. So most of you are saying no. Acha guys, let me ask you this first. I'm expecting this, that you have already studied the ray diagrams for formation of image in convex mirror and in convex lens and in concave lens in your standard 10. सबने पढ़ा है. Like if object is at infinity, where the image will be formed. If object is beyond 2c, where the image will be formed. Sorry, beyond 2f, where will be the image? If object is at 2f, where will be the image? If object is between f and 2f, where will be the image? All these things you must have studied already. Okay? So when we use the ray diagram, when I say a ray parallel to principal axis will pass through focus after refraction, is this rule for ray tracing requires a special condition that lens should be thin? Does this ray tracing formula, does this ray tracing rule that one ray which will be parallel to the principal axis passes through focus after reflection, does this require a condition that lens should be thin? ये आंसर कर लो, कहानी खत्म. If you answer this, you'll get the answer for this question as well. Because everything we have never talked about this ना, ये तो हमने देखा ही नहीं. Thin है वो तो हमने देखा ही नहीं. We are just talking about this. Parallel है तो यहाँ जाएगा. We are just drawing the ray diagrams here. If you draw these ray diagrams here, these triangles will always be like similar to each other, like these angles will be same only. ठीक है, फर्क पड़ेगा प्रतीश, फर्क पड़ेगा. फर्क ये पड़ेगा if that does not pass through focus, तो image कहीं और बनेगा. If that does not pass through focus, then it will not be parallel. It will be somewhat like this. It will be somewhat like this. तो triangle कुछ अलग बनेगा. But this ratio will not change. But this ratio will not change. So I can say this Newton's law or Newton's lens equation will be applied or will be applicable for thick lens also. ठीक है, ये जो हमारा इक्वेशन बनता है किसके लिए? This is applicable for thick lens also. You can use this for thick lens also. तो यहाँ x1 x2 क्या अगर thick lens भी रहेगा तब भी x1 x2 is equal to f1 f2 ये वैलिड रहेगा, आपको कुछ टेंशन लेने की जरूरत नहीं है. बट एनीवे नाउअडेज वी डोंट यूज दिस फॉर्मूला. बहुत ही कम बुक में ऐसा आपको क्वेश्चन मिलेगा इससे रिलेटेड. बट इन नीट, स्पेशली इन नीट एंड सीईटी एंड समटाइम्स इन बोर्ड, द क्वेश्चन विल बी आस्क्ड टू यू लाइक दिस इन बोर्ड्स. राइट न्यूटन्स लेंस इक्वेशन. इन सीईटी they'll give you the object of the or like object distance from focus, and they'll give you this focal length, and they'll ask you what is the distance of the image from the focus. तो तरह तरीके से आपसे क्वेश्चन पूछा जा सकता है. So that is why I have included this in your class. All right guys, now let us move on to transverse magnification or magnification. ठीक है, when we talk about only magnification, if I'm not using any transverse or longitudinal, we have to consider that as a transverse magnification. So what will be the magnification for a lens, or what will the value of magnification when refraction occurs through a lens? तो consider को बच्चा लोग, this is the lens. ये lens ऐसा कुछ बनाया हुआ है. So after refraction, the ray of light is passing through. So there are two ray diagrams that we have drawn. There are two rays that we have used. One which is parallel to principal axis passes through focus after refraction. The other one is what? The ray passing through optical center goes undeviated. So using these two ray diagrams, we have drawn an image here. So this is the object, this is the image. What will be the magnification here? Hi divided by h naught. Hi divided by h naught. Now if you use this triangle, देखो ये एक triangle ये use करता हूँ मैं. In this triangle, can I say tan theta will be equal to h naught divided by u? If I use this triangle, can I say again tan theta will be equal to hi by v? If I divide equation 2 by 1, I will get hi by h naught. Hi by h naught will be equal to v by u. Hi by h naught is nothing but magnification. Hence, we say magnification for lens is nothing but v by u. Lateral magnification for lens will be equal to v by u. तो ये फॉर्मूला आपको याद रखना है. Guys, if I ask you about longitudinal magnification, how will you get it? What will be the formula for longitudinal magnification? तो यहाँ पे एक condition आपको रखना है. What condition बच्चा? If object is small. If object is small, then ml will be written as dv by du. It will be written as dv by du. We know a relation between v and u. What is that? 1 by v minus 1 by u is equal to 1 by f. If I differentiate this relation, this equation with respect to u, I'll get 1 by v square into dv by du minus 1 by u square is equal to 0. So from this part, I will get dv by du is equal to, यहाँ से dv by du क्या मिलेगा बच्चा लोग? तो उधर जाके माइनस प्लस हो जाएगा, तो माइनस v square by u square. What is v by u? तो m. तो what will I write? m square. So what is the value of ml बच्चा लोग? तो ml is nothing but minus m square. All right, guys. चलिए. So this is the formula for longitudinal magnification. अच्छा, what if object is not small? What if object is not small? If object is not small, if object is considerable in size, or if object is large, then magnification ml will be written as delta v divided by delta u. Delta v divided by delta u. तो आपको ये पार्ट यूज करना पड़ेगा. What is delta v बच्चा? तो difference between the image distances for the end points of the object. V2 क्या है? V2 is the image of the point, or if I consider this is an object. If this is point 1, this is point 2. If this is U1, V1 will be the image distance for this point. If this is U2, V2 will be the image distance for this point. तो delta V delta U का मतलब क्या है? Image distances of the end point of the image. U1 क्या है? Delta U क्या है? Object distance for the end point of the object. We have already solved some questions related to this. But boards में हमें anyway पढ़ना नहीं है, बस सिर्फ derivation सिर्फ definition समझ लो, बाकी और आप boards में पढ़ना नहीं है. I'll solve some numericals also related to this in competitive classes. All right, guys. Now, if I ask you what will be the deviation that a ray of light will experience while passing through a lens. So what will be the deviation, bacha? So for that, I'm going to consider a parallel ray of light striking a convex lens. If a parallel ray of light incident on a convex lens, it will pass through focus. Now, can I say that this was the original path? Now, this is the actual path followed after refraction. So the deviation is nothing but this angle. This angle is considered as del. So deviation is given by del. So del कैसे निकालेंगे बच्चे लोग? So if you look at the diagram, I can say in this right angle triangle diagram, I would write tan del is equal to h divided by f. What is h बच्चे लोग? So h is the object distance. If you have considered an object here of height h, so actually h is nothing but the object distance. So h by f. So if I ask you what is the value of del, you'll say del will be equal to tan inverse of h by f. If del will be small, जो कि होता है normally, it will be very small. Why? Because we talk about thin lenses. We talk about when deviation is not that high. So if del is very small, you can say del can be written as directly h by f. So for smaller deviation, the deviation angle can be considered as the ratio of the height of an object divided by, or the ratio of height of object and the focal length. So h by f is called as deviation if deviation is small, or tan inverse of h by f will be the deviation if deviation is not that small. ठीक है बच्चा? तो ये हो गया deviation का formula. Guys, click yes if you have understood till this point. बच्चा लोग click yes if you have understood till this point. यहां तक अगर समझ में आई बात तो फिर click करो yes. Guys, in ray optics थोड़ा सा आप लोग क्या करना है, like you need to revise these things one more time after the class, because there are so many theoretical concepts that are being taught to you, and you can only remember them if you solve some numericals and if you revise them properly. Now, next topic that we are going to study is power. ठीक है? No problem with this, but after class में नहीं बता पाऊंगा. चलिए. So next topic that we are going to study is power. So guys, what is power of a lens? So as you can see the definition of power on the screen, the power of a lens is the measure of its ability of producing or of producing convergence of a parallel beam of light. Or you can say it's the measure of its ability of, ये क्या लिखा है? Ability to produce. ये off नहीं होना चाहिए, it should be to produce. So the measure of its ability to produce convergence of a parallel beam of light. So what is the ability of the lens to converge a parallel beam of light? ठीक है, तो कितना converge कर पाता है? That ability has been termed as a power of the lens. ठीक है बच्चा? So convex lens of larger focal length. A convex lens of larger focal length produces smaller converging effect, because देखो, if these are the two parallel rays of light. यहाँ पे हमने लेंस रखा. If these two parallel rays of light converges at a very large distance, ठीक है, if these two rays of light converge at very large distance, what is the value of f? Can I say this is nothing but f? So if f is large, the convergence occurs at a large distance. So क्या बोलेंगे बच्चा लोग? So convex lens of large focal length produces smaller converging effect, and a convex lens of smaller focal length produces a large converging effect. Due to this reason, the power of a convex lens is taken as positive, ठीक है? And a convex lens of smaller focal length has higher power. छोटा फोकल लेंथ मतलब नजदीक में कन्वर्ज किया. Larger focal length, that means converges, like the rays of light are converging at a very large distance. So convergence क्या हो गया, कम हुआ. That is why क्या बोलते हैं बच्चा लोग, तो let me underline this. A convex lens of smaller focal length has higher power. So power will be inversely proportional to the focal length. All right. On other hand, a concave lens produces divergence. It is being talked about when the medium is having lesser refractive index. When the medium or when the surrounding is having lesser refractive index. So on other hand, the concave lens produces divergence. That is why we consider power of a concave lens as negative. Acha, what is the unit of power? So unit of power is diopter, which we represent as capital D. A convex lens of focal length 1 meter. If focal length of a convex lens is 1 meter, the power of that lens will be called as 1 diopter. Okay? So the focal length of a convex lens is 1 meter. If focal length of convex lens is 1 meter, we will call the power of that lens as plus 1 diopter. The convex lens of a focal length 2 meter will have a power of plus 0.5 diopter. How do you get this? So mathematically, you have to write power is equal to 1 by focal length in meters. This part is important, बच्चा लोग. ठीक है? So focal length in meters. So when focal length is given to you, you have to use the length or the focal length in meters only. Don't just put the value of focal length in centimeter. You'll get wrong answer. So you have to convert that centimeter into meter to get power in terms of diopter. All right? बहुत बढ़िया. So all right, guys. I think time हो गया है. So this is all about today's class. So let us end our class here only. Tomorrow or day after tomorrow, whenever we will meet, we'll start with some numericals and then we'll move on to combination of lenses. कुछ numerical solve करेंगे. Then we'll move on to combination of lenses in contact. ठीक है? फिर कुछ और derivations पढ़ेंगे, फिर कुछ numerical solve करेंगे. So thank you guys. Thank you for attending the class. Stay safe, stay healthy. Enjoy, my guys. Thank you. Bye-bye. Take care. Yeah, today was so much of theory. Correct. No problem, guys. I think you can handle it. Bye-bye, guys. Take care.